Welcome to another episode of Wave FEA Tutorials. This is your host Mac, and today we are going to talk about method to set up nonlinear static analysis for large rotations. Large rotations, also referred as deflections, come under geometric nonlinearity. This becomes a concern when the part deform such that the small strain assumptions are no longer valid. In a case like this, nonlinear static analysis provides more valid results than linear static analysis. Let us jump right into the tutorials. Let us first set the units of measurement to English system. Let us now define the material. Click on the material in the command manager, rename the material as spring material, enter the density as 8.02 to the power of -9, Young's modulus as 1.9 to the power of 5, and Poisson's ratio as 0.22. The idealizations can now be defined. Click on the idealizations in the command manager, select shell elements under type from the drop-down menu, and enter thickness as 0.05 inch. Click on idealizations again to add another line idealization as bar element. Ensure the associated geometry option is checked and select lines to join at the spring. Select cross section under input type and click on button I next to it. Enter the cross section area for the bar element as 0.2 inch for dim 1 below end A. And click on draw end A to get the end area. Click OK to close. Double click on the mesh model to define the mesh details. Enter the global element size as 0.05 inch. Select element order as linear and generate the mesh. Let us now define the constraints. Click on the constraints in the command manager and constrain the inside face of the spring in all the directions. We can now define the loads. Click on the loads in the command manager, select enforced motion under type and rotation under subtype. Enter the rotation of 3.14 degrees in RY direction and apply the load at the junction of the bar elements. To visualize the applied load, check preview and click OK. Change the analysis type to nonlinear static and ensure that the large displacement is turned on under the Options tab. Double-click on the nonlinear setup in the analysis tree, define the number of increments to 25 and set the intermediate output to on. Now that all the conditions are defined, we can run the analysis. Once the analysis is complete, right-click on the results in the Wave FEA tree and click Edit. Here you can observe the deformations and stresses for all the 25 increments. Click on the Animate button to see the stresses and displacements animations. Thank you so much for joining us today. This is your host Mac signing off. For more information, visit our website www.wavefea.com. You can also opt for a 30-day free trial of Wave FEA software by registering with us on our website. We will be back with more features and updates from Wave FEA. Thank you.